So yeah, hello everyone. A very good evening. I hope I'm audible and visible. Can anyone confirm it? So let's wait two to 3 minutes so that everyone can able to join the session. Okay, let's start the session. Hello everyone, my name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Shantanu Chattopadhyay, Electrical and Electronics Engineering Department at IIT Kharagpur. This is the week 3 live interactive session on digital circuits. I hope all of you have gone through this week video lecture. So now we will solve some problems based on your assignment problems. Okay. And you can use the chat box for interacting and asking the question. And also I would like to suggest you please carry one not required calculator but somewhere for solving the problems. So these are the topics which have been covered for this week. So these are the topics which have been covered for this week. This is the outline for this week content. First one is minimization of Boolean expressions. Then what are the two ways of solving the problems of Boolean expression? First one is algebraic, another one is using Karnaugh map, or in short we can say K-map. Then implicants, what are the implicants? Prime implicants, essential prime implicants. And then logic gates, what are the different types of logic gates? AND gate, OR gate, NOT gate, logic buffer gate, NOR, NAND, exclusive OR gate, and exclusive XNOR gate. These are the some topics which have been covered for this week. Okay, first recapitulate some points for related to this week, then we will move to the questions. Okay, so first one is the minimization of Boolean expression. So as already told you, there are two methods are widely used to reduce the Boolean expression. First one, algebraic method, where we use different Boolean rules and theorems already which have been covered in the last week or week 2 are used to simplify the Boolean expressions. And another one is a K-map or Karnaugh map, which is proposed by Maurice Karnaugh in 1953. That is refinement of the Edward, which is 1952 Ritz law. Okay, K-maps are convenient way to simplify the Boolean expression. They can be used for up to 4 to 5 variables. They are a visual representation of a truth map. From the truth map, we can solve the or derive the Boolean expressions. Another one is implicants, prime implicants, and essential prime implicants. So what is a implicant? So implicants are the every min term in SOP or a max term in false form, product of sum form in a Boolean expression is termed as a implicant. So here example is given. For example, F is equal to AB plus AC. So AB and AC are called implicants. And what are the prime implicants? Prime implicants are the all pairs that cannot be a part of any chord, or all chords that cannot be part of any octad in a K-map are termed as a prime implicant. Okay, so all the pairs as already know that the K map, that the example of three variable K map. It is a A or BC, where it is a 0 0 0 1 1 1 and 1 0 0 1. So all the pairs that cannot be, for example, if there is a chord means the combination of the four pairs that cannot be part of chord, or chord that is not a part of octet in kernel is termed as a prime implicants. And what are the essential prime implicants? Essential prime implicants are those implicants that cover at least one minterm and that cannot be covered by any other prime implicant. Why prime implicants cannot be a part of octet? That can be a part of, it depends on the problem. We will solve the problem, then we will go to in deeper mode. Okay, so these are the some theoretical concepts which we are going through so that we can able to solve them. Okay, so next one is a binary quantities and variables. So already we know that how we can represent a binary quantity. For example, it is a simple binary arrangement to light up a lamp. So this is a battery, and the battery is connected to the switch. Okay, so this is a normal binary, a simple binary arrangement. For example, if it is giving 0, so that switch will be open and output will be 0. That lamp will not light up. If that 1 means we are giving the power, and it will be just like this, that light will be on. And the binary arrangement of two switches in a series is also called a AND gate representation. Okay, this is a battery. There are two switches connected in series, right? So for two switches, two variables are required and one output. That means that we need to on or off the light. For example, if both are open, then it is 0. If any one is open or another is closed, for example 0 1 or 1 0, then output 0. That means if any one is open and closed, that the electricity will not pass. In that case, lamp will not light up. So in both cases, it is 0, and if both are closed, that means 1 1, then it will be on. Okay, so these are some simple binary arrangements for AND gate or gate. It is also called series. Previous and AND gate representation also called the series representation. This is called parallel. When two switches are connected in parallel, so it is called OR representation when it is connected in a parallel. So S1 or S2. So this is a truth table for this binary arrangement when we connecting the two switches in a parallel. So in that case, if both switches are open, then the current will not flow. That will be off only. If any one will be open or closed, in that case the light will be light up. Okay. And another one, series and series parallel connection. In series parallel connection, where we are utilizing both and or. So this is a binary representation, series and parallel connection, and this one is a truth table. But here what we are going to, here we are using three switches, so three variables, three combination we need to represent. So these two are parallel. So anyone if on or off, it will be off. That means off. Then light will be light, but S1 must be the on. That means in that case the output will be 1. In all other cases the output will be 0. If S1 is 0, in any case if S1 is 0, then the all output will be 0 because it is open, then current will not able to flow. If S1 is closed, in any of both situation, then light will be light up. Okay, in one situation 0 0, if both are open, it is closed and both are open, in that case current will not flow. In that case it will be the 0. In all other cases it will be the 1 only. So these are the some simple binary arrangement: series connection, parallel connection, series and parallel connection. Okay, so next one is the logic gate. So already we have gone through the logic gates. What are the different logic gates? So logic gates are building blocks used to create a digital circuit. There are three elementary logic gates that are AND gate, OR gate, and NOT gate. And each gate has its own logic symbol, which allow complex function representation by a logic diagram. The function of each gate can be represented by a truth table or Boolean function. Okay. So these are the some logic gates which diagram, circuit diagram or a truth table and Boolean expression representation is given here. The first one is AND gate. AND gate is represented by this symbol, and this is a truth table of AND gate, and this one is a Boolean expression. So AND is basically a multiplication of two variables A and B. Okay. So AND gate is represented by this diagram. And what is a truth table? Truth table already told you, AND is a representation of multiplication of two variables. So we need to just multiply. So what are the possible combination of two variables? That is 0 0, 0 1, 1 0, and 1 1. So when if we multiply 0 0, 0, and 0 1 also will be 0 only. 1 0 is also 0, and 1 1, 1 into 1 will be the 1 only. So this is it. AND gate to travel, and similarly the OR gate representation is represented by this symbol. And already told you, OR is a addition of two variables or three variables. It depends on number of variables. Okay, so here it is a two input or two variables. So here two input are there, so two variables are given. So simply OR gate is a addition of two variables, and AND gate is a multiplication of two variables. So here we are taking two variables only. So possible combination, then just add 0 0 0 will be 0 1 1, 1 0 1 only, and 1 1 1 only. Okay, in the OR gate. Next one is a NOT gate, or also called inverter. The inverter is represented by this symbol. Simple. It is a one input. It has only always one input, and just it invert the output input. Okay, for example, if output is B, the input is A and output is B, so output will be the A bar. If we are giving 0 here, then we will get 1. If you are giving 0 1, then you will get 0. Okay, just inverted. It is the Boolean expression for AND gate is A bar. And similarly, a logic buffer gate. Logic buffer means whatever you are giving, you will get the same. If you are giving here 0, you will get 0. If you are giving 1, we will get 1 only. So B is equal to A. Next one is NAND gate. So NAND gate it is like a AND gate, but inverter symbol is attached in the output. So Boolean expression for NAND gate is A B bar, and gate is a multiplication, so it is also multiplication also with the inverter. So when you are giving, it is also two variable representation, only here two variables are there. So if we are giving 0 0 in the AND gate, you will get 0 only. So 0, but bar is there, so you will get 1. That means inverted output of an AND gate. Similarly, in the NOR gate also the symbol is, it is a inverted representation of a OR gate. It also added two variables. Okay, so whenever you are adding two variables, for example 0 0 will be 0 only, but here bar symbol or inverter is attached, so it will give the output 1. So it is just inverted output of a OR gate. Okay, so we need to just remember the Boolean expression and their symbols. We will able to find out the truth tables. Next one is the exclusive OR gate and exclusive NOR gate. So exclusive OR gate is represented by or XOR gate. It is also called XOR gate, and it is X NOR gate. Okay, so the for XOR gate, that is the symbol to represent the XOR gate, and but XOR gate Boolean expression is different. So XOR gate is represented by, this is a XOR symbol of two variables. Okay, and if you simplify further, I hope all of you have gone to, so it is represented by A bar V plus B bar A also. It is represented by this one also. Okay, so for XOR gate, when the inputs are different, for example, if inputs are same, it will give the 0. If inputs are different, so it will produce one output. From here you can solve it. For example, A XOR B, and the simplified expression of A XOR B is written here. So if A is 0, so that means 1. A bar is there. So A is 0, so A bar is 1. But B is 0, so B is same. And here B bar, so B, if B is 0, it will be the 1, but A is same, so 0. So you will get 0. That's why 0 is here. Now if you solve for 0 1 or 1 0, so for 0 1, so A is 0, so A bar will be the 1 only, and B is already 1, right? Plus here B bar A, so B bar is 1, sorry, B is 1, so B bar will be 0 only, and A is 0, so 0 0 0, here you will get 1. Similarly, it will happen for 1 0 and 1 1. Okay, next one is XOR gate. The XOR gate is represented by this symbol, and the Boolean expression for XOR gate is this one, A XOR B bar, or it is also represented by this symbol dot, then it is XOR representation, this one, and it is also, so the simplified expression for XOR gate is A A bar B bar plus AB. Okay. XNOR gate is opposite to the XNOR gate. So when both inputs are same, then output will be 1. When the inputs are different, then output will be the 0. Okay. So if you want to solve and so that from here, for example, if both inputs are 0, so here 0, A and B are 0, so A bar or B bar will be the 1 1, right? 1 into 1, and AB is 0 0, so 1 only. Output is 1 for 0 0. And for 0 1, here A bar, A is 0, so A bar will be the 1. And B bar, B is 1, so B bar will be 0 only. Plus AB. So A, we have to multiply. So 1, 0, 1. So 0 plus 0 will be 0 only. So will be the 0. Similarly, you can do for 1 0 and 1 1. Okay. Okay. So these are the some gates which we are going to use for solving the Boolean algebra problem. Next one is combinational logic or sequential. So in digital circuit, there are two broad categories are divided. First one is combinational logic or another one sequential circuit. In sequential circuit, we will study later, but whatever you are currently seeing, that is come under the combinational logic. So what is the combinational logic? Where the outputs are determined slowly by a current state of the input. Whatever currently given, output it depends on that only. But in the sequential circuit, where the outputs are determined not only the current input but also by the sequence led input from the current state. Okay, current input as well as whatever so in the current state, or you can say that in the previous input also, it depends on, because there is a feedback combination will be there in the sequential logic. We will see it later, the sequential circuits or sequential logic. This is the example of the combination logic or combination circuit. So how you can solve using this logic gate? How you can find out the Boolean expression? This is called Boolean expression. So this is a NOT gate, this is a AND gate, and this is a OR gate. Okay, these are added. These are added in some fashion so that you can get the output. For example, one input we are giving the OR gate, and B is giving AND gate, and C is giving to the NOT gate. So what will be the output of the NOT gate? C bar will be there, and it is giving to AND gate another input. So B into C bar will be the output of AND gate. Now we have to add all those things. One input is we are giving A, and another input is B C bar. So it is a OR, so we need to add A with this quantity expression or quantity. So A plus B C bar. So this is an example of combination logic or solving a Boolean expression. Okay, now we are moving to the questions or problems. So the first problem is the following Boolean expression equivalent to. So here the function is given, this is in some SOP form. Okay, so f is x, y, and z 0 to 4 5 6. It is a given, means that in that places there will be 1, and all other places that will be the 0 only. Okay, so can anyone able to solve this? How we can move forward using algebraic method or K-map? So for solving using the K-map, so it is a 3 variable. So how many cells will be there? Yeah, correct. 8 cells will be there. So it is a x, y and z. So it will be the 0, 0, 0, 1, 1, 1, 1, 0. It is a 0. Here it is 0 and 1. How you will cross check you are going in a right direction? This is a x, this is a y and z. So it is given means in truth table in these places there are ones and all other places there will be a 0. Okay, so in the place of 0 that means 0 when the combination are all three 0, then output will be 1. This is a output, for example x, f is x, y and z. You can directly put it in the K-map or you can make a truth table if you are not understanding. Then this is the x, y, z, this is the f. Okay, so where in the truth table in these places, for example 0, 0, 0, then 0, 0, 1, here in the place there is no one, so in the place of 1 it will be the output will be the 0, and if in the 0, 1, 0 it is a 2, so in the place of 2 there will be a 1. Similarly 4, 5, 6 at these places there are 1s and all other places all are zeros. Okay, so here how we can map that? That means x is 0, so just check here is 0, so 0, 0, 0, x, y, z, we are going in this direction, so 0, 0, 0. So in the place of 0 it will be the 1 only. Okay, right? It is a representation of 0, it is 1, it is 2, it is 3, right? And the rows and columns are arranged in a gray label. Okay, always remember this. So why it is 0, 0, then the 0, 1, and not is following the sequence, it is a 1, 1, then 1, 0, because it is arranged in a gray label sequence. We will see it. I have one question on that. That is it. So here it is 0, in the place of 0 it is 1, and another one here it is 0 because there is no one, so it is a column 2, so here it is 1 and there is no 3, so it is also a 0. Then 4 in a in term 4 it is 0, so 1, 0, 0 is a representation for 4, no? It will be the 1, right? Then which one is 5? It is a 5, so here it is also 1, and at the place of 6, 6 it is 1. Okay, so this one is 6 if you able to calculate. So what is the binary representation for 6? That is 1, 1, 0, right? So just check, it is a 1, 1, 0. Okay, so in the place of 6 it will be the 1, and there is no 7 is there because all are 1, so it will be the 0 only. So map all these ones in a K map. Okay, then what we need to make a pair, right? Or pair or chord or octet. Just we need to check from where we can make a pair. So these two are in a adjacent places, so these make a pair, and from here we can also make a pair. This is a chord, right? So I hope you are getting. So how now? First we need to find out this for pair. Yeah, one chord, one pair, right? So what is the Boolean expression for this pair? Let's write it down. So here it is 1. 1 means x only. If it is 0, then x bar. If it is 1, then it is x only. And just we need to check this in this line, the upper one. What is it? The expression for this. So what will be the? Here we need to check what is a common in between. So 0 is common. 0 means y bar, right? Yeah. x y bar representation for this pair. And what is the representation for chord? Here 0 1, then both will be cancel out. If you are writing x bar or x, it will be the cancel out. Okay, so we need to take this, just need to corresponding column. So what is the common in between these two? 0 is common. Okay, so the Boolean expression for this chord is will be the z bar, right? So we need to, this is a sum of product form or SOP form we need to write. So z bar. Now what is coming? X y bar plus z bar. Yeah. And the what you want to ask and answer is C. Yeah. So x y bar plus z bar. The correct answer is option C if you match it. Okay. Okay. So moving to the next question, it is also based on a K map, but here what is given? Here it, the symbol is given pi. So what is the representation? That means product of sum form. Here product of sum form is given. Okay. So for these places, the input are zeros, and all other places out that in the truth table output will be the zero. So just remember, if just check this one, it is pi or summation. For summation, if it is a summation is given, that means SOP form, and if pi is given, it is a false form. So okay, just we need to check on this. So that means in these places this is a zeros are given. So but uh, we need to check the in the output. So how many cells will be there? There are 4 variables, right? 4 variables. So 16 cells will be there. A B C D 0 0 0 1 1 1 1 0. Here also 0 0 0 1 1 1 1 0 will be there. So if you move in this way, 0 1 2 3, okay, then 4 5 6 7 8 9 10 11 12 13 14 15, like this. So in these places we need to put zeros. In these places we need to put zeros because it is given in the product of sum form. Okay, so in the place of 1, it is we need to write 0. So it is 0, first one, first cell is 0, second one is 0. Okay, and at one places it is given 0, then at which places we need to write 3 1, I mean at 3. So 0 1 2 3, here will be the 0 only. Now check at fifth places we need to write 5 0. So 0 1 2 3 4 5, here will be the 0 1, then 7th, it is a 7th, then 13 and 15, 5 6 here, and here we need to write down. So here it already it is given a product of some form, so we can make it from here also. So here what we can make 2 chords, we make this with this, but remember that we need to write in the product of sum form. Okay, so for this what will be the expression for this chord upper one? So here what is a common? 0 is common, so product of subform में what we are going to for 0 it will be the a only, not a bar, because it is already product of sum form. Okay, now we need to check in those two columns what is the common. 1. So for 1 we need to write in bar form, so t bar, right? Because it is a product of some form, so it is written in this. Otherwise we can write in other manner. For example, a d bar in the sum of product form, but in the pos form it is a plus t bar. And for this, what is for this code, what will be the expression? Just check what is the corresponding row and take a common. So here 1, so that means b bar plus what is it? Common d bar, right? Now product of some form, so just we need to multiply product of sum, means that these are the sum and product of these variables, b bar plus d bar. Okay, so which one is option? Just check in the options which one is correct. So option D is the correct answer for this question. So I hope all of you are getting these questions, how you can solve this using the KMath. Okay, so moving to the next question. The next question is also based on a KMath, but here the min terms and don't care conditions are given. So in the place of don't care, we need to write x, right? And the place of these places, we need to write 1. So here it is also a 4 variables, so 16 cells will be there, right? So first we need to make a KMath. So 16 will be there. So this line I am assuming AB, and this one is C for D, right? Here already we know that the 0 0 0 1 1 0 and sorry 1 1 is 1 0. It is a 1 1. Just 1. 0 0 is 0 1, then 1 1 1 0. So it is 0, then 1, then 2, then 3. We are moving in this direction. So where are the min terms? So at the place of 9, right? So just check where it is 9. So 9 will be the place of 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9. So 1 is here, 9, then 10, 12. 1 is here, right? These are the points where we need to put 1, and all these places we need to put don't care condition. So in the place of 3, 5, 6, 7. So 0, 1, 2, 3. That means here. Then 5, 6 it is here, and 7, 8, 9, and 11, 13, 15, and this one is 14, right? 7 will be left. So 0, 1, 2, 3, 4, 5, 6, 7. Okay. So these are the places we need to put. Now we have to, what we need to do? Now we have to make pairs, whether it is a chord or a octet or pair. So we can see that for in this place there will be no, don't care, so 0, 1, 4. This is in 4, sorry, this by mistake it is written Okay, so these are the some places. Now what we can need to do, we here from here we can make a chord, right? uh, and which places we can make a chord, any other places? So just always remember, if there are only don't care conditions, so don't need to make a pair, or if there are ones, then we can make only. Okay, so just cover all ones. So there is one pair. So for this, what is the expression? What will be the expression? The one is AB, and all these terms will be cancelled out if you write and multiply. So it is for AB, and next for this, what will be the expression for this? Just check corresponding rows. So it is a common A. One is common, so at this place A will be there, and corresponding column also, what will be the common? C. And similarly for this chord also, A will be common, and correspond, if you check corresponding column, then D. Okay, so what will be the boolean, final boolean expression for this K-map? That is AB plus this is B, AC plus AD, right? So just match with the options and check it out. So AB plus AC plus AD. Okay, so option C is the correct answer for this question. Option C is the correct answer. Okay, so moving to the next question. The next question is given, the sum of product for the following expression is given. Now we need to write a corresponding min term. Okay, the expression is given. Now we need to write the corresponding min term. So either you can make a truth table, or from the K map also you can get the min terms. At which places? It is X, Y and Z. This there are different ways also to solving these problems. You can solve in any way. I'm just taking a K map because this has been covered in this week. So just practice more and more. This 0, 1, and here 0, 0, 0, 1, 1, 1 and 1, 0, right? So now first we need to check the x, y. From where we can get the x, y only. So x means 1, right? Only 1. If x bar is written, that means 0. So we need to just check x means that 1. That means in this row. Now next one is y. We need only y. So from where we can get only y? Common. So if you take these two columns, so y bar will be there. Okay, because 0 we need to take, and from here you can take 1. So 1 means y only. So that means 1, 1 will be there. So from this pair you will get only x and y. If you want to solve, you can solve it. So if you make a pair, then you will get corresponding from the corresponding row x only, and here from here y only. So that means for the expression xy or implicant xy, the corresponding cells will be the in this corresponding cells will be the 1, 1. Now we need to take another one. The another one is y, z, right? Now how we can get a yz from the corresponding K-map? So yz, that means in these four columns, any of them. But we need to check yz. So yz get only in this column, column number 3, right? So just we need to write it here. So if you make a pair like this, you will get only y, z. Now, next one x, y bar, z, right? Now, how you are going to solve the x, y bar, z? So just check from where you can write. So x, y bar is given. So x means there is no bar, so that means this row, y bar, z. So where is y bar, z? That means this one. So from here, you have to write it. Okay. So all the expression will be completed. From here, you will get x, y. From here, you will get y, z. And from this one, x, y bar, z. Here we can make, but the pairs but we have to x, y bar 0 is given. So that means 1, 0, 1. So just check in this manner also. So 1 will be there only. Okay. So from this one, you will get x, y bar, z. So what is corresponding cell? It is 0, it is 1, it is 2, and it is 3. That means 3. Right? One column is 3 and it is 4, then 5. So 5, it is 6, 7. 6 and 7. And this is sum of product form. So summation. Okay. So answer will be f x y z is written x is equal to summation 3, 5, 6 and 7. Right. So these are the answer. Just match with the answers. So it is 9, 3, 5, 6, 7 option B. Option B is the correct answer for this question. Okay. So have you understand this? How would you solve this type of problem? Okay, yeah, great. So I hope all of you getting to moving to the next question. So next question, truth table of a circuit is given. Now we need to find out the Boolean expression from this truth table, right? So let's solve this question. So we can solve it from by taking here also directly where it is 1 and write their Boolean expression, or by using K-map also, both, but I am taking here directly. So the output from Z is when we need to check the corresponding variables. So A at which place 1 at which at 1 it is output is 1. So what we write A bar, B bar, C, right? For this one. Now next where it is 1 at 2. That means A bar, B, C bar, right? Where the next one, the in the output here in this place. So A it is 1. So A and at the 0 0. So B bar, C bar plus. Now next one is in the last one. All are ones. So A B C, right? A B C. So this is the Boolean expression for this truth table. But what we need to do, we need to simplify it more. Okay. So just check what we can take a common. So I'm taking from these two first. That means A bar, right? So here what we will get, B bar C plus B bar B C bar, right? Now in the next two, we will get what we can take common, A, right? Then what we will get, B bar C bar plus B C. Now, okay, now next, what is the expression for this one and this one? This is the XOR gate operation, XOR gate expression. That means B bar C plus, yeah, and the next one for B bar, C bar and the BC, it is for with and BC bar. We can write it B XOR C, right? For this one. And similarly for this is the XNOR gate operation, XNOR gate expression, B bar C bar plus B C, and it is represented by this symbol. Okay, so I am here writing A bar, that means B XOR C plus A B NOR C, right? And in the previous slide we also see that XNOR is a just opposite of or inverter of XOR gate. Okay, so this expression we can we XNOR C is also we can write in this form, B XOR C bar, right? We can write it in place of B XNOR gate to this one. A, so if you write it in place of this, so you will get A, so it is not a bar, A B bar, right? Now I'm removing from here so that we can write it. Okay, so now check. Now what is the expression for this? What is A? Let's assume that this is X. That means assume that this B XOR C is equal to X. And here then what you will get? X bar, right? Because B XOR gate C bar. So X bar will be the X bar. So A bar X plus A X bar. Now it again XOR gate, XOR of A X, right? Now again put the value of X, that is B XOR C. So what you will get? A XOR B XOR C, right? In place of X. We assume that B XOR C in order to simplify this expression. Okay. So what you have get? B XOR A XOR B XOR C. So what will be the answer for this question? Option C. A XOR B XOR C. Okay. So I hope you have understand this question. Can we move to the next question? Okay. Moving to the next question. So what will be the output for this circuit? How you will solve? What will be the output for this circuit. What will be the expression for f? So let's solve it. So what will be the output of this? This is an AND gate representation. This is a NAND gate. Okay, this one is a NAND. These both are NAND gate. So what will be the output of this NAND gate? That means A multiplication of B bar, right? Similarly for this, the input is CD given. So output of this NAND gate will be the CD bar. Now the output of here, the inverter is also applied, right? In before the this input, so AB bar and then again bar. Here also CD double bar. So F will be, it is a OR gate, so just add AB double bar plus CD double bar. Now it is double, so you can remove it directly, AB plus CD. Okay, so option B is the correct answer for this question. Okay, AB plus CD. Okay, so moving to the next question. So in K-map simplification, a group of 4 adjacent ones leads to a term with, what will be the correct answer? A, one literal less than total number of variables. Option B is 2 literals less than the total number of variables. 3 literals less than total number of variables, or 4 literals less than the total number of variables. Yeah. But can you answer me why B is correct? Yeah, B is the correct option, correct. But why and how? In K-map simplification, a group of 4 adjacent ones leads to a term with. So as we know that group of 4 cells, right? This is it. Just time. Group of 4 cells means this one. That means how many variables will be there? 2, right? X, Y or AV. So okay. And this group of 4 cells, if all are ones, and then they can make a quad. Okay. So it will illuminate only 2 variables. Yeah. Changing terms are eliminated. Okay, yeah. So 2 literals less than a number of variables. A group of 4 cells is called and it eliminates 2 variables. Okay, a group of 4 cells eliminates the 2 variables. So option B is the correct answer. For example, if there are to the power m cells will be there, right? So m variables will be there. Okay, and that m variables eliminate the m minus 1 literal. Okay, so option B is the correct answer for this. So moving to the next question. So the code used for labeling the cells of a K-map is, which code is used for labeling the K-map? B. Someone is answering B also. Okay. Yeah, correct. Gray code used for labeling the K-map. So how you will find out the gray code is used for labeling? So already we know that here it is 0 0 0 1 1 0, sorry 1 1 and 1 0, right? Similarly here also 1 1 1 0. So these are the gray codes. For example, 0 0 0 1, 1, 0, and 1, 1. It is a binary representation, right? Already we know that. And if you change it in a gray code, so how you will change it? I think I don't know whether have you studied till now or not. Just I am telling you. So if two symbols is like this, so just write it first as it is, and these two will be the XOR each other for the next place. So 0 XOR 0 will be the 0 only. Okay. So the gray code representation corresponding this is 0, 0. Now next one, what will be the, so 0, the first place is write down as it is, and for the next place just XOR these two terms. So 0, 1, 1. Similarly for this one also, so in the first term it is written 1, and for the next term we need to XOR, so 1, 1 will be there. Now for the next term, first one as it is, and for the next term we need to XOR it. So 1, 1, 0 will be there. So for the binary, because this is the gray code. So here it is written in a gray code. Okay. That's why it is written in a gray code representation. Okay. So option C is the correct answer for this. The code used for labeling the cell map. This is the labeling. K map is gray code. Okay. So moving to the next question. An n variable K map can have how many cells will be there if there is a n variables? 2 to the power n, correct. For example, there are n variables, n is equal to 3. Okay, so 2 to the power 3 cells will be there, that means 8. Already we know that for 3 variables, this is a K map representation, right? So total number of cells there, here x, y, z, that means these are the 3 variables, and total number of cells 1, 2, 3, 4, 5, 6, 7, 8. Similarly for 4, n is equal to 4, so 16 will be there. So for this is the K map. So 16 cells will be there. So 2 to the power n cells will be there for n variable K map. Here 2 to the power n cells will be there. So correct answer is C for this question. Okay. So moving to the next question. So next question is, which of the following represents the sum of product expression for the function f is equal to wx y z is given. That means in these places there are ones are there, and in these places there are don't care conditions will be there. So let's solve it. So how many variables are there? There are 4 variables. So that means 16 cells. So make a K map. And I would like to also suggest to please solve with me so that you can able to practice better. And also this is live interactive session, so try to interact and solve with me so that you can interact. What will be the answer? And so can anyone tell me what will be the answer for this? Okay. So wx in this for this side and yz for this side. I am taking. You can take in any direction. 0, 1. So 0, 0, 0, 1, 1, 1, and 1, 0 will be there. Okay. So that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just map with the places. So 0, 1. In these places there are 1s. So at 0, then this is one is 0. Then this one is 1. In these places there are 1s. 0, 1, 2, 3. Okay. Then 4, 5, 6, 7, there are no. Then 8, in the place of 8, there is don't care condition. Then 9, 10, 11, 12, 13, 14, in the place of 14, 1, and the place of 15, there is a don't care condition. Okay. So I think this is a mapping of ones and the don't care condition in a K map. So now what we need to do, just make a pairs or chords, just check what we can make. So there is one pair, right? There is one pair and there is also one pair, and here we can make two types of one with this or one with this. Okay. So before making, you just need to check for which pair the options will be there. Okay, they can take both or they can take in one. So let's write down the corresponding expression. So for this, what will be the expression? Here 1 there, so that means wx, right? And the corresponding column, what will be the y, right? For this, and what will be the expression for this corresponding pair? Can anyone tell me? Yeah, option C is correct, but just right now tell me what will be the expression for this corresponding pair. So check the corresponding to, that means W bar,
W dash dash
yeah, W dash,
X dash
yeah, and
YZ.
no, for corresponding this, what will be the common? Z,
YZ.
Z, Z will
Ah,
be common. And for this one, can you tell me for this one? So W dash will be the
dash
common,
X dash.
and Y
Mm,
dash
Z.
Z.
YZ. Z.
Yeah. And for corresponding this one, so 0 will be common, that means X dash, and here it is not only one row, so we need to write the corresponding expression Y dash Z, right? So just need to write it down in SOP form and check which answer will be matched. So WXY plus X dash Y dash Z dash plus W dash Y dash Z plus W dash X dash Z, right? So just check which options will match better. So you can choose anyone so that it is easier to find out which option is correct. So just I'm taking WXY is there. It is in three options will be there. Now next take the another one, X dash Y dash Z dash, X dash Y dash and Z dash in this Y dash and Z dash. Sorry, X dash Y dash and Z dash. There is some mistake. I have written X dash, yeah, and then 0 5. Yeah, this one is correct. X dash Y dash and Z dash in this. Now next one, W dash Y dash Z, W dash Y dash and Z. Okay, W dash X dash and Z. So just check with the answers which one is correct and mark it out. So I think here one mistake will be there or anything else. Here option C is correct, but X dash, Y dash and Z dash. WXY is correct. So there is either, I think B is correct. It is 19. Okay. So just match, or otherwise from here you can also make a pair. So there is one option also is there. Okay. This is the answer. Just stick with the option B or C. They can be both. Okay. So moving to the next question. So next question is, what is the minimum number of two input NOR gates that are required to implementing a two input XNOR gate? Okay, we have to make a two input XNOR gate using two input NOR gate only. So first we need to write down what will be the expression for XNOR gate. Let's expression is represented by a symbol Y. Two input is X and Y. X and Y we are giving the two input. So what will be the expression for XNOR gate? That is X bar, Y bar plus XY, right? This is the XNOR gate representation.
No, madam.
Yeah, it is XNOR gate. XNOR gate is given, not
Ah,
XOR gate.
ah,
XOR gate is X bar Y plus Y bar X, right? And this is given the XNOR gate. Okay. So now, how? What is the representation of NOR gate? Already we know that NOR gate is represented by this symbol. Two input X, Y. You can take it Z. X, Y, two are the inputs and Z is the output. So Z is represented X bar, Y bar plus X, Y, right? Now, how we can find out, we need to get this expression by using two input NOR gate. So how many minimum number of two input NOR gates are required? So let's take first one. So here we are giving X, Y, right? So what will be the output of this? X plus Y bar. So try to make it out how many NOR gates are required. So let's check. So X is giving the next output and Y is given. So X and Y, it is given to both NOR gates one input, and X is given here and Y is given here. So now check what would be the expression. So expression is here X plus Y bar, right? And what will be the output of this NOR gate? Y plus X plus Y bar. Anyone can solve it out. What will be the other expression for this? I am solving for upper one, X plus Y bar. Okay. So if you break it, X into, that is X bar, X plus Y double bar, right? It is double bar. So that will be the cancel out x bar. That means x plus y, right? If you multiply further, so x into x bar plus x bar y, that will be 0. What left? X bar y. So this expression is equivalent to x bar y, and similarly this expression is equal to x y bar, right? Now we need to take this and give to the another NOR gate and check whether the output will come or not. So x bar y plus x y bar, this is the output. Okay, now solve it. X bar y plus x y bar del. Now x dash y here multiply. In place of plus there will be a multiplication. X y bar. Now further if you solve this, then you will get x double bar plus y in 1, and this is multiplication, so x y bar will be there. So x bar plus y double bar. Okay, now x plus y bar, where I can solve, I'm solving it here, just check. X plus y bar, and in the next x bar plus y. Okay, now multiply and you will get x bar plus xy plus x bar y bar plus y bar. So these two terms will be 0. You will get xy plus x bar y bar, which is the expression of this XNOR gate. So how many NOR gates we are required to solve the XNOR gate? There are 1, 2, 3, 4. We require 4 NOR gates to solve the XNOR gate. So there 4 NOR gates are required to implement 2 input XNOR gate. Okay. So that's why on option B is the correct. 4 NOR gates are required. Okay. So have you got this question? If any confusion, you can ask. Okay. So I hope all of you understand this question. So moving to the next one. So here the question has asked which of the following is not an essential prime implicance of a function f of a, b, c, d. 4 variables are given and min terms are also given. Now what we need to do, we need to find out the which of the following is not an essential prime implicance, which one of the following is not a. So can anyone solve it and just let me know which option is correct using key math? Which of the following is not a essential prime implicance? A, B, C, D. 0, 0, 0, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 0. So these are the places where we need to put ones: 1, 4, 5, 10, 12, 13, 14, and 15. So 1, 2, 3, 4, 5, 6, 7 is not available. 8, 9, 10, 11, 12, 13, 14, and 15. So now one chord is there and another chord is there, one pair is there and one pair is there. Okay, so what are the corresponding? Just check what are the essential prime implicants. Actually, this one is wrong. So just don't concentrate on this. I will change it. Okay. So here it is those prime implicants that cover at least one main term and that not covered by other prime implicants. That can be covered. Okay. So yeah, someone is answering. So A bar C bar D. Okay. A B C bar plus A B plus B C bar. Yeah. So just check which one of not of the essential prime case. So for what will be the expression for this? A C D bar. A C D bar. And for this chord, there will be B only for this chord AV will be there. And for this, what we can write? B C dash. And for this A bar C D. Okay. So just check with the options A bar, C bar, D is there, and AB is also there, and this one is BC. So BC is not in the option, and ACD bar, ACD bar also is there. So which is not available? So AB, AC, D bar, ACE, these are available only. Option C is not there. Okay, B, C bar, D. So just check B, C bar, D. C bar D is this one and B is common. That means they are asking for this. So this is not a essential prime implicant. Just go with the options which are available, then check. Okay. So option C is the correct answer. It's not a essential prime implicant. Okay. So moving to the next question. So next question is simplify expression for Boolean function. The function is given, that is A bar B bar D bar plus A bar C bar C bar D bar plus A bar B D plus A B C bar D. Okay. So that means there are four variables are there. So we need to make a four variable K-map and try to find out the corresponding cell value. Okay. 0 0 0 1 1 1 1 0. And also you can solve it by truth table also. Just write it down from there. 1 0. So whatever way you find easy, you can solve it by this. You can take it by the truth table also and from here also. Okay. So just check where what will be the corresponding cell value for this. Just check first one for so A bar, B bar, D bar. Okay. So first one is A dash. That means if you take these two rows, so A dash will be common. A dash, B dash. Just check A dash, B dash. A dash, B dash means this row, right? Now D. D dash means 0 will be here. So this can be okay. Expression for a dash b dash d dash. Okay, a dash b dash and d dash. Right now, check to the next expression a dash b dash c dash d dash. That means all must be 0. So that can be a first cell only from where you can get a dash b dash c dash and d dash, right? So this already it is 1. So don't need to write again. So now move to the next a dash b d. So a dash b, where from which row we can find out? This row, a dash b, right? Now d, from where we can make d, only d common. So in this column and in this row, so if you make a group, you will get a dash b and d. Now the expression is a b c dash d. So a b in this row only we can get, because it is 1 1 1. So a b. Now next c dash d. So where is c dash d? So it is 0 c dash d, means this one. Now all the expressions are got completed. So write down the corresponding cell value in order to write out in terms of SOP form. So you can write out like this. So it is 0, first one 0. It is 0, 1, 2, 3. 1, then 2, then 3, 4, 5, 6. So 4 and 6, right? Sorry, 0, 1, 2, 3, 4, 5. It is 5 and 7, 7, and it is 13. This one is cell number 13. So I can write again. It is 5 and 7, right? So this is 0, 2, then 3, 4, so 1, 2, 3, 4, 5, then 6, 7. And this one is 13. Okay, just check with the answers. 0, 2, 5, 7, 13. 2, 5, 7, 0, 2, 5, 7, 13. Option D is the correct answer for this. Okay. Okay. So moving to the next question. Now, which of the following gate is equivalent to the given circuit? So circuit is given. Just find it out the O, the expression Y. My pen is not working. Just a minute. Otherwise, you can solve it. I am just giving you direction. Just let me know what will you will get. So from here, you will get it is not gate, right? This is not gate. So what will be the expression output? Here it is a bar only, right? You can say a dash, and this is NOR gate. Yeah, just check. Here it is a bar. Here it is a plus b bar. Okay. Here it is a plus b bar, right? Now add this is OR gate, right? This one is OR gate. This OR gate will add these two expressions. That means here it is a bar, a plus b bar that will added, okay, in this side. And similarly in the another side, what you will get in another side? Here b dash plus b plus c dash, b dash plus b plus c in brackets dash. Now if you solve this and this, you will get what you will get. You will get a plus b only if you solve it. So a plus b, what which gate it is? That means it is ORing to gate. That means this is going to be OR gate only. So option B is the correct answer. Just a minute, I'm checking what is going on. So just a minute, I'm sharing another tab so that you can able to see. So now are you able to see my screen? Can anyone confirm it? Can you able to see my screen? Okay. So here what we will get? A bar. Here a plus b bar. Now here you will get a bar plus a plus b bar, right? And similarly here you will get the final. Here it is b bar, b plus c bar corresponding this NOR gate, and here you will get b plus b bar plus b. Now multiplication, it is a NAND gate, right? So a plus b bar, here multiplication with b bar plus b plus c bar and 4 dash. Now if you remove that dash, a plus b, dash here and plus will be there. So you will get b dash b plus c dash. Okay, now again, if you so a double dash in multiplication a plus b double one, right? Plus similarly here b double dash plus no, it is multiplication. So just it is multiplication. So b plus c double dash, right? Now it is a, all the bars will be removed. So a into a plus a into b, right? In this, and similarly here b into b, b plus b into c. So a plus ab plus b plus bc, right? Now take here one common, so you will get 1 plus b, right? And if you take here common b, so here you will get 1 plus c, right? In these two, so 1 plus b and 1 plus c is a 1 only, already you have seen. So you will get a plus b. And what is this? This is a OR gate, right? This is a OR gate. So option B is the correct. Okay. Okay. So I hope you are understanding. So moving to the next question. Next question is the Boolean function f and their corresponding min terms are given. Simplify this. So again, by using K-map, we can get the answer. There are 4 variables, so 4 variables K-map look like this. So A, B, C, T, right? 0, 0, 0, 1, 1, 1, and 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Now we need to write down corresponding places value. All these are ones, so we need to put ones. So from where? So 3, 7. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 12, 13, 14, and 15. In these places we need to. Now there are one chord and there is one pair and one pair. So we need to write down corresponding value all zeros. So only CD for corresponding this chord, right? And for corresponding this pair, the expression will be, what will be there? Only one row will be there, so AB, and corresponding column value is C because one is common. Now next one is for this pair, what will be the value? AB same because same row, and what will be the corresponding column value? 1 is common, so 1 means D. So expression, what will be the expression? ABC plus ABD plus CD, right? Okay, so I hope you are getting. So which one option is correct? It is matching option B, so option B is the correct answer for this question. Okay. Okay, so I hope all of you understand this question. So moving to the next. So next question is the Boolean expression for the following would be. What will be the Boolean expression for this case? So that means it is corresponding one. In this places the corresponding ones we need to put, and is for the D denotes the don't care condition. So corresponding this the don't care condition we need to put. Okay. Okay, so there are 3 variables are only. So that means 8 cell K map will be there. A, B, C. 0 0 0 1 1 1 and 1 0 0 1, right? Now we need to put the corresponding values. So 0 in the place of 0 there is 1, then in place of 2 and 6 1, it is 0 1 2 3 4 5 6, here will be the 1, and don't care condition will be in place of 1 3 and 5. So 0 1 2 3 4 5 here. Yes, now make a pair. This is one pair and another one. No, not this one. There is a chord that will make. Now we need to write down what will be the value of corresponding this expression. Can anyone answer it? 4. Yeah, option is 4. That is fine. But what will be the expression you will get corresponding this pair? It will cancel out, and here it is B, C, bar. Now write down for this chord. Here only one row it is covering, that means A, and all those things will be cancelled out. So what will be the expression? A bar plus B, C, right? So which option is correct? Option 4 is the correct answer for this question. Okay. So moving to the next question. So next question is, for the given map, already K map is given, find out the minimum product of sum. That means first we need to find out product of sum. That means corresponding zeros we need to corresponding zeros we need to make a pair. So I'm directly making here. So we need to check zeros only because the product of sum is given. So we can make no one chord here, and where we can make other places these two, right? And where we can, here product of sum is given, not a SOP, it is POS. So we need to check the zeros only, not ones, and here we can make it. Now we need to write down the corresponding product of some values. So what will be the, so there all values are given, so this will be the cancelled out, rows will be the cancelled out, we need to write down only column values. So 1 or 0, that means A bar plus B in a product of sum form. Okay, A plus B, A bar plus B for this. And what will be the value for this one corresponding? Here it is only one row, so corresponding row value, what will be the, I'm writing it here. So what you will get? C bar plus B, right? Now check corresponding columns. So what will be the common? 0 will be common, that means plus A, right? Now write down for corresponding this one, I'm writing it here. So what will be the common? 0, 0 means C plus, here it is A plus B bar, right? Now write it in product of sum form. So I am starting A plus B bar plus C. It can be write it like this. And next one is A plus C bar plus B. Now A bar plus B. Check which option is correct. A plus B bar C, A plus C bar D, A bar plus C. It means option 2 is the correct answer for this question. Okay. I hope you are getting. Okay. So moving to the next question. So what would be yielded for simplifying the following Boolean expression? We need to simplify this Boolean expression, then check which option is correct. Okay. So expression is A plus C dash plus C plus C plus C dash. The whole dash. Now A plus B dash plus C, that is here multiply. In place of addition you can add multiplication. B plus C dash. Now A dash B C dash, right? B double dash will be cancelled out. I'm writing it here directly, and here B dash C, right? Now multiply and you will get A dash B, B dash C, C dash, and that both will yield 0. So whole function will be 0 only. So y will be 0. Option 3 is the correct answer for this question. Okay. Okay, so I hope all of you getting. So moving to the next question. So next question is simplify expressions for the following Boolean function. So A, B, C, D and their main term values are given. We need to find out the options which correct. It can be multiple options also. So that's why here it is given multiple expression also. So by using KMath we can solve it. Their 4 variables are given. So 4 variable KMath will be like this: A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0 will be there, right? So write down 0, 1. So in place of, in these places we need to put ones, right? So 0, 1, 2, 3. So 0, 1, 2, 3. Then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are the places where we can put the ones. Now we need to simplify. One chord is there, one chord is there and one pair. We can make by using this one or this one also. So we need to check in both. So first we need to write for this chord. So A dash, B dash only, because that will be cancelled out. Similarly for this AB only, and first we need to take this one. So corresponding row value will be A dash C D dash, right? If we can make it pair with this one, then what will be the, we need to take any one. There can be two expressions, right? It is given. So first one is A dash B dash plus AB plus A dash C D dash, right? Just need to check which one. A dash B dash AB plus A dash C dash, this one. Now which can be another one? So that can we make a pair with this one also. So B will be common and C, C bar. So another expression can be A dash B dash plus AB plus B dash C D dash, right? So yeah, which one? B, only B. It is not a dash, right? Because we are making on this, so one we need to take common. So B, C, D dash. So another expression will be this one. So which options can be B and D? So option 4 will be the correct answer for this question. Okay. So these two can be expression. We can represent F1 or F2, right? So I hope all of you getting this. So moving to the next question. So next question is the number of essential prime implicants for the function y is how many essential prime implicants. So already here it is given the 4 variables. That means 4 variables K map we need to draw, and these expression will be given. Now we need to put it into this K map, then find it out how many essential prime implements can we make. So AB, CD, 0, 0, 0, 1, 1, 1, 1, 0. So here 0, 0, 0, 1, 1, 1, 1, 0. Right? Now A dash, B dash, C dash, D. Which corresponding which cell we can put it? A dash, B dash, right? So A dash, B dash in this row we can get. Now next one C dash, D. C dash, D means this one, right? So if you put, you will get A dash, B dash, C dash, D, right? Now check for the next expression A dash, B. So A dash, B from where we can get from this row, and C D dash. C D dash means 1, 0. That means this one, right? You will get A dash B and C D dash. Next one is AB C dash D dash. AB, here it is 1, 1. So you will get from this row, corresponding this row. Now C dash D dash. So the C dash D dash this one. So this one, right? So there are no pairs are can be made from this one. So total number of essential prime implicants are 3 only, because 3 expressions are there, right? And there are no pair and no chord, no nothing is getting made. So 3 implicants. Okay, leave it with there. So option 3 is the correct answer for this question. Right? Yeah, correct. Option 3. Now moving to the next question, and this is the last question. This will be the last question. Okay. So consider the K map given below. We need to consider this K map where X represents the don't care condition. These X and blank represents the 0. Okay. And corresponding ones are given. Assume all for all inputs A, B, C, D, the respective complement A bar, B bar, C bar, D bar are also available. That means the A, B, C, D, A bar, B bar, C bar, D bar is also available. Nothing, we no need to take the NOT gate, right? The above logic is implemented using two input NOR gate. Now we need to make the these first we need to find out the Boolean expression for this. Then for these Boolean expression we need to implement using two input NOR gate. Okay. Then the minimum number of gates is required. Then how many gates will be required? That means we don't need to consider this NOT gate, because already complemented inputs are also available. We don't need to use the OR gate, sorry, NOT gate, right? So first we need to find out the expression for the corresponding. So we can make a group of chord here, right? Because these are the don't get conditions only, so we can't consider these. So only one pair we can make. So let's y is representation for this expression. So what will be the value? So here what is the common? C. And for these columns, what we can take common? A, right? From this 0 will be common. Here A is written in the opposite direction. Just remember here it is not given. DC means D this value, C this value. Here B this value, A this value, right? Always see the which sequence it is given. Okay, so that means this represent the A bar, right? So what will be the expression? A bar C, right? For this K map. Now we need to implement this using this expression. So how we can make? Can we use NOR gate? Because already complemented input is available, right? Two inputs we need to give. So A bar C if we are giving, or if we are using NAND gate, so can we get A bar C? If you multiply A bar C bar, you will get, right? Here. Or you can use AND gate only, because complemented input is given. A bar C, you will get directly A bar C. This is one way. Another way you can use a NOR gate, but here it is given. To input NOR gate we have to consider. So what you will get? The output A bar C bar, right? But we have to get it like in another way. So if we can take not this bar, if we take C bar, then what you will get? The corresponding output A C bar, right? If you take now, if you A plus A double C bar, right? So what you will get? A bar plus C here, right? No, I'm getting just a minute. If you are giving A here and complemented input is here, what will be the output? Here you will get A plus, right? A plus C bar, A plus C bar whole bar. Now we can solve it. So A double times bar, A plus will be C bar. So you will get A C bar, right? Sorry, A bar. Just a minute. I'm doing it, clearing it out here, because we have to use here it is given to input NOR gate only. So there is this is a not option. This is also not option. We have to use only two input NOR gate. So if we are directly giving the A bar into C, then the output will not come. Okay. So if we give the in the another format A, and for this we are giving the C bar. Okay. So what we will get? A plus C bar output. Now we need to solve it. So if you solve A bar into C double bar. Now double bar will be cancelled out. You will get this answer if you give this. So this is a NOR gate representation of this function. Okay, because already here given, assume all the inputs ABCD, the respective complements are available. So already available, don't need to use NOT gate for getting C bar. Okay, it is available. So only minimum number of gate, that means only one gate is required to implement this logic. Okay, so I hope all of you get this point. So this one is the last question. So if you have any doubt, you can ask. Otherwise, we can close this session. Okay. If you have any doubt, you can ask. Otherwise, we can close this session. The questions are completed. Okay. I hope all of you understand these questions. Otherwise, we can close the session. So anyone have? Okay. Please appreciate it. Yes, someone is asking. Implicants and the prime implicants. Okay. Actually, in this slide, just a minute. Are you able to see? Here it is wrong, but implicants are all those values. This AB and AC are implicants, and prime implicants you can check in the which make the any pair or any thing. Okay, see these are the prime implicants. Okay, and if you going to the essential prime implicants, so the maximum pair you can make. So there are multiple options are also there, multiple possibility to make a group. For example, for this one with this one with this one with this one, right? So these are the prime implicants, right? And if you make with this one and this one, these are the essential prime implicants. Hello, here it is written that can be covered at least here it is can be corrected, and in this one is also wrong. I will correct it. Okay, and will then upload it again. Hello, are you getting? In this slide it is written is wrong. I will correct it and will then will submit it. Okay, so don't go with this uh, concept. Me another one, if you have doubt on the questions or how to solve the question, you can ask. Otherwise, we can close this session. Okay, thank you everyone. Thank you for joining. So now we can close this. Okay. Thank you everyone.